Welcome to MESCOE Lab. In this tutorial, we will learn stress analysis of cantilever beam and simply supported beam. We will be using Autodesk Fusion 360 for our analysis. So, let us get started. Let us start with creation of project. Go to Show Data panel, click on New Project. Give your project a proper name. I will give it as Modeling and Analysis. Press Enter. Now our project is created. Let us open our project. Double click on project that we have created. Now our project is open. When we open Autodesk Fusion 360, by default an empty design is created. Let us save this design. Click on Save button. Give a proper name to your design. I will give it as Model 1. Click on Save. Now our design is saved. Now let us check dimensions and loading conditions for our beam. In this tutorial, we will be creating a beam of length 130 mm having rectangular cross section of dimension 26 mm by 21 mm. For cantilever beam, we will be fixing one end of our beam. That is, we will restrict X, Y and Z translation. Also, we will be applying load of 1000 Newton in negative Y direction, that is in downward direction. And we will be checking stresses at 76 mm from load or at 54 mm from fixed support. Now let us create model. Let us create sketch. Click on Create Sketch. Select plane that you want. I will select XY plane. Select rectangle and draw a rectangle of dimension of cross section of beam. I will give it height as 21 mm and width as 26 mm. Press Enter. Now let us position our sketch with respect to center. Click on Sketch Dimension, select Center and select Edge. Give it distance as half of height of our cross section, that is 10.5. Press Enter. Again select Sketch Dimension, select Center, select Edge. Give it distance as half of width of our cross section. Now our cross section for beam is ready. Click on Finish Sketch. Click on Home. Click on Extrude. Select side as one side and give it distance as 130 mm, that is length of our beam. Click on OK. Now our model for beam is ready. Now let us perform analysis of cantilever beam. Go to Design drop-down, click on Simulation. Click on Static Stress and click on Create Study. Now our static stress study is created. Let us apply material to our beam. Go to Material drop-down and click on Study Materials. By default, steel is allotted to our model. Let us allot another material other than steel. Select drop-down under Study Material column and select material that you want to apply. I will select Aluminum 6061 T6 cold form. Now we have applied material to our study. Let us check properties of material that we have applied. Click on Properties. You will see properties of material that we have applied in the right window. For Aluminum 6061 T6 cold form, we get density as 2.7 e to the power minus 6 kg per mm cube. Young's modulus as 69 gigapascals. And so on, we get properties of material. Click on OK. Now we have successfully applied material to our beam. Now let us apply constraints. In cantilever beam, one end of our beam is fixed. To apply constraints, go to structural constraints, select type as fixed and select face. Keep all axes as fixed because one end of our beam is fixed. Click on OK. Now let us apply load. Click on structural loads, select type as force, select edge or you can select face as target. I will select face. As you can see, by default, load is applied in Z direction, but we want load to be applied in negative Y direction. To do so, select direction type as vectors and give Fy as minus 1000 Newton, that is load in negative Y direction. Click on OK. Now we have successfully applied constraints and load to our beam. Let us generate mesh. Right click on mesh and click on generate mesh. Now our mesh is ready. Let us solve our beam. Click on solve drop down and click on pre-check. A pop-up will come which will say that study setup has all the information required. This means we have followed all the steps that are required for analysis. Click on OK. Now let us solve our beam. Click on solve drop down, click on solve. Here you get two methods to solve our beam, that is one on cloud and one locally. I will solve it locally. Select locally and click on solve. Now our solution is complete. Close this tab and you will see we get minimum safety factor as 5.7. Click on close. Now let us check stresses induced in the beam. Click on the drop down and select stresses. Here we get maximum stresses in the red zone, which is 64.72 megapascal. Here red zone represents maximum values and blue zone represents minimum values, while green zone represents values between maximum and minimum. Now let us check stresses at 54 mm from left end, that is fixed end, or 76 mm from right end. Click on create point probe, select any point and give a proper position to the point. I will give x as 0, y as 10.5, which is half of height of our beam, that is upper fiber of our beam. Now let us check stresses at point which is at 54 mm from fixed end or 76 mm from right end. Now let us check stresses at point which is at 54 mm from fixed end and 76 mm from right end. Click on create point probe, select any point and give it x distance as 0, y distance as 10.5 and Z distance as 76 mm. We are giving Y distance as 10.5 mm because we are considering top fiber of our beam, which is at 10.5 distance from neutral axis. Also, we are giving 76 mm in Z direction because we are calculating stresses at point 76 mm from free end. Click on OK. As you can see, we get stresses as 39.87 megapascal at that point. Now let us check strain value at that point. Go to drop down and click on strain. Here we get strain as 5.206 e to the power minus 4, while we get maximum strain as 8.519 e to the power minus 4. Let us check displacement at that point. Go to drop down and click on displacement. Here we get displacement at 0.1256 mm at that point, while we get maximum displacement at 0.5314 mm. Let us go to stresses. Now let us compare our stress value with simulator. This is the simulator developed by our team. You can download this simulator from our website. Link for our website is given in the description. As you can see, according to simulator, we get stress values as 39.769 megapascals and strain values as 0.000576. You can also compare your answer with analytical solution. So this was the stress analysis of cantilever beam. Now let us perform stress analysis of simply supported beam. For simply supported beam, we will be considering length of beam as 130 mm, having cross section as rectangular cross section of dimension 26 mm by 21 mm. For simply supported beam, we have hinge support at one end and roller support at other end. We will be applying load of 1000 Newton in downward direction, that is in negative Y direction, at 40 mm distance from roller support or 90 mm distance from hinge support. We will be calculating stress value at 20 mm from hinge support or 110 mm from roller support. So let us start with analysis of our simply supported beam. This is the beam model that we will be considering for our simply supported beam. Here cross section for our beam is 26 mm by 21 mm and length of beam is 130 mm. To check length of our beam, click on Inspect or Measure, select one face and select other face. You will see we get distance as 130 mm, which is length of our beam. Now let us perform analysis for simply supported beam. Go to Simulation, select Static Stress and click on Create Study. Now let us apply material to our beam. Click on Materials drop-down, select Study Materials. By default, steel is allotted to our beam. Let us allot another material other than steel. Go to drop-down under Study Materials column. Select material that you want. I will select Aluminum 6061 T6 cold form. Again, I will check properties for our beam. Click on Properties. You will see Properties of material in the right window. Here Density is 2.7 e to the power minus 6 kg per mm cube for our material. Young's modulus is 69 gigapascals. Poisson's ratio is 0.33. And so on are the properties of material. Click on OK. Now our material is applied to our beam. Now let us apply constraints to our beam. Click on structural constraints. Select type as fixed. Select edge. We are selecting edge because one of the support for our simply supported beam is hinge support. Keep all axes as fixed, that is translation along Z, X and Y direction. Click on OK. Now we have successfully applied constraints to one end of our beam. Now let us apply constraints to other end. Click on structural constraints. Select type as fixed. Select edge and unselect UZ. That is, we are allowing translation along Z axis. Click on OK. Now we have successfully applied constraints to our beam. Let us apply load. Before we apply load, let us split upper face of our beam in two parts so that we can apply point load at distance of 40 mm from right end. Click on Simplify. Go to Construct drop-down and select Offset Plane. Select plane and give it distance as 40 mm. Click on OK. Now go to Modify. Go to Split and select Split Face. Select Face. Select Splitting Tool as Plane and click on OK. Now our upper face of beam is split into two parts. Let us hide the plane that we have created. Go to Model Components, go to Constructions and select on I. This will hide our plane. Now click on Finish Simplify. Go to Structural Loads. Select Edge and give it load as -1000 Newton. Click on OK. Now we have successfully applied constraints and load to our beam. Let us generate mesh. Right click on mesh and click on Generate Mesh. Now our mesh is generated. Let us solve our beam. Go to Solve drop-down and click on Pre-check. A pop-up will say that the study setup has all information required. That is, we have followed all the steps that is required for analysis. Click on OK. Again, go to Solve and click on Solve. Select locally and click on Solve. Now our solution is complete. Click on Close. As you can see, we get safety factor as 15. Click on Close. Now let us check stresses induced in the beam. Click on drop down and click on Stresses. Here we get maximum stresses as 13.83 megapascal. Now let us check strain values. Click on drop down, click on strain. We get maximum strain as 1.86 e to the power minus 4. Let us check displacement. Click on drop down and click on displacement. We get displacement at 0.03043 mm. Again go to stresses. Now let us check our stress value at 20 mm from left end and 110 mm from right end. Click on Create Point Probe, select any point, give X distance as 0, Y distance as 10.5 and Z distance as 110. Click on OK. Here we get stresses values as 3.103 megapascals. Let us check strain. Go to drop down and click on strain. We get strain value as 4.065 e to the power minus 5. Now let us check reactions. Click on Inspect drop down, click on Reactions. Select the edge to which we have applied constraints. Here we get reaction as 307.692 Newton. Deselect first edge and select second edge. Here we get reaction as 692.308 Newton. Click on Close. Now let us compare our answer using simulator. According to simulator, we get stress values as 3.22022 megapascal at 0.20 mm from hinge support, that is from left end, and strain value as 4.6669 e to the power minus 5. We get reaction as 307.692 Newton and reaction at other end at 692.307 Newton. You can also compare your answer using analytical solution. Now we have completed stress analysis of cantilever beam and simply supported beam. In next part we will learn stress analysis of fixed circular shaft. For more information about our VLab, please visit our website. Link for our website is given in the description. Thank you.